Hey everybody, we are in chapter 1, lesson F, part 1, solving equations algebraically and graphically. I'm actually going to have the graphically portion of solving these equations on a separate video where I can show you my graphing calculator. So anyways, let's get to it. Objectives, we're going to solve equations, linear, quadratic, and cubic algebraically. Let's go ahead and get to it. Okay, so what it means to solve an equation. To solve an equation means to find all x values, or whatever the independent variable might be, for which the equation is true. This can be done using either an algebraic method or a graphical method. So I'm going to go ahead and start here with the algebraic method on the left. And as you've probably done many times before, this is an equation. And the reason it's an equation is because there's an equal sign there. Later on, we're going to get to inequalities where we have greater than or equal to, less than, all that good stuff. So as I solve, in this case, what I'm going to do is I can do this a couple different ways. I could either solve for x squared, set it equal to 4, take the square root of both sides, and you may or may not know this, but the square root of x squared is equivalent to the absolute value of x, and the square root of 4 is 2. So if the absolute value of x equals 2, then x equals plus or minus 2. Okay, another algebraic way that you can solve this is to factor the original equation. You want to factor only if you've got a 0 on one side. Therefore, I could factor this to be x plus 2 and x minus 2. And the zero product property allows us to know then that either one or the other of these factors has to be 0 in order for their product to be 0. Therefore, x would either equal negative 2, as seen here, if I were to set x plus 2 equal to 0, or x would be equal to positive 2. That is the two of the algebraic methods we're going to use today. So let's look at a graphical representation. Let's say that I label these axes, and each of these grid lines is a 5 or a negative 5. And I sketch the graph of x squared minus 4. Well, if I sketch that, x squared minus 4, and I were to shift the parent function, which we've done most recently, okay, then what I can do is I can sketch the graph of x squared minus 4. It'll look something like this. Okay, of course, I'm doing this without plotting points, although I did plot this point, the point 0, negative 4. But if I were to plot points, this point here would be 1, negative 3. This point here would be negative 1, negative 3. And then these 2 points here would be the solutions. The solutions would be 2, 0 and negative 2, 0. So look at that. I found that x equals negative 2 and x equals positive 2 are solutions. And I also showed that that was true on the graph. Notice how this equation was asking where x squared equaled 0. And we found that. We found that x squared equaled 0, right? This is y equals 0 at those 2 points, 2 and negative 2. So let's get into it using some of our methods. Okay, so on this slide, I've got an example in part 1 of a linear function, part 2 of a quadratic, and then also part 3 of a quadratic. You can see that the highest power in parts 2 and 3 are both degree 2. Those are called quadratics. So let's go to number 1, and let's solve this. I'm going to rewrite it so that it's in a form that's a little bit more traditional. My math type on my computer just is not working as well as I'd like it to, so I'm going to rewrite it like that. Now, I could do this a number of different ways, but what I'm going to choose to do is I'm going to get a common denominator. So let's go ahead and do that. So that would be 4x over 12 plus 9x over 12 is equal to 2. All right. There is another method I could use. It's called clear fractions. I will do that in a later example, and you'll see why that's beneficial as well. So if I add these two together, I get 13x over 12 is equal to 2. Of course, I can solve a linear equation somewhat easily here. I'm going to multiply both sides by 12, so 13x equals 24, therefore x has to equal 24/13. So this should be the solution to that equation. Okay, let's go on to number 2. Number 2 is kind of a weird one. Okay, I got a quadratic equal to -4, but what I can do is I can turn it into finding the zeros or solutions by setting the right side equal to 0. Notice how now I potentially could factor. That's one of the methods we'll use in this section. Okay, I'm looking for two numbers that multiply to 4 and add to -5. So multiply to 4, add to -5. How about -1, -4? So it looks like the solutions here for x will be a +1 and a +4. So if I were to sketch that function, it would look somewhat like this. Oops, that was a -4. What am I doing there? How about a +1, a +4? And the graph should look something like that. Okay. All right, so let's look at part 3. Part 3 is very similar to 2, got a little bit more to it. So I'm going to add 2x squared to both sides. That gives me x squared over here. I'm going to add 12x to both sides, which gives me a 7x over here. And then I'm going to add 10 to both sides. And look at that. Now I've got a much cleaner, nicer looking quadratic. Hopefully I can factor it. If you can't factor in a given situation, you may remember this, but you're going to have to likely use the quadratic formula. So let's go ahead and factor. I believe this is factorable. Two numbers that multiply to 10 and add to 7 are 5 and 2. Okay, and if one of those factors is 0, then the product is 0. Therefore, x plus 5 is either equal to 0 or x plus 2 is equal to 0. That means that x either equals -5 or -2. Awesome. Okay, so let's go on to the next slide. We're going to talk a little bit about more methods that we can use to solve these equations. Okay, when solving polynomial equations, not including absolute value or square roots, we have the following methods available to us. One is factoring. We did a couple questions like that on the previous page. 2 is extracting roots. We'll talk about that also here on the next page when I run through these problems you can see below. 3 is the quadratic formula. Now the quadratic formula only works with a quadratic function setup, okay? It can work for higher degree polynomials, but they're very unique, and we might see a couple of those throughout the semester. And number 4 is factor by grouping. This is a different type of factoring, of which we'll see a couple of examples here. So you can see each of these are type 1. We're going to end up factoring these using different methods. Type 2, extracting roots. We'll look at those. Type 3, quadratic formula. And type 4, this will be a factor by grouping method. So let's go ahead to the next slide and execute on these questions. Okay, so let's find the solutions to the following equations. Let's start with all problems of type 1. So let's factor the first problem. It looks like it's in a form that I like, where I've got one side equal to 0. Two numbers that multiply to 4 and add to -5. I think we already did this problem. I'm going to have x minus 1 and x minus 4. If I solve those two linear equations, I would find solutions of 1 and 4. Excellent. So the solutions to that equation are x equals 1 and x equals 4. Okay, the second example within the factoring style question, we don't quite have ready to factor yet, so I'm going to subtract 4 over, making this x squared minus 36. You might recall that this is a difference of two squares, so x squared minus 36. It's a difference of two squares, so I can factor it. In this case, if I were to write this out as x squared plus 0x minus 36, what I'm looking for is two numbers that multiply to -36 and add to 0. In order for them to add to 0, they have to be the same. So I would have x plus 6 and x minus 6. That gives me zeros, or solutions, of -6 and +6. Okay, let's move on to the third example in part 1. Okay, here is an interesting quadratic form with a quartic degree. Okay, so check out what I can do is I can look for, I've got an x squared here and an x squared here now instead of an x and an x like in previous examples. But I'm still looking for two numbers that multiply to 30 and add to negative 11. I could say negative 5 and negative 6. The reason this works, and you'll see here right here, let me point this out. Okay, in previous examples I had an x squared, then an x, then a constant. Here I have an x to the fourth, x squared, and then a constant. If I didn't have, let's say I had x to the fourth and x cubed, this method would not work. It's got to be x to the fourth and x squared and then a constant. Okay, so I can solve both of these separately. Okay, I could solve where x squared minus 5 equals 0. Well, that would be where x squared equals 5, and therefore x would equal plus or minus square root of 5. Same thing would be true for x squared minus 6 equal to 0. I would also get plus or minus square root of 6. So notice how in this case there are 4 solutions. And guess what? This is a 4th degree polynomial. Therefore, many times you can get 4 real roots or 4 real solutions. There are some cases where you would only get 2 or possibly 1 depending on the degree of the polynomial, but we're going to get to that in a later date. Okay, the 4th example, this is a really good example. It looks very similar to the 3rd example, the one right above it. But what I can do is I can factor out an x, leaving me with x squared minus 11x plus 30. So now I'm going to hang on to that x on the outside and I'm going to factor the inside. So I would have x minus 5, x minus 6. So now I've added a root basically. So I've got three zeros, a synonym, I'm not an English teacher, a synonym for solution is root. That is a synonym for solution, okay? Now, I have now 3 solutions. I would have x equals 5, I have x equals 6, and I have x equals 0. Okay, awesome. Let's look at the second type. It's called extracting roots. Now, extracting roots is actually a very convenient form for us to have. So for example, if I have x plus 4 quantity squared equals 25, I would take the square root of both sides. So what we would get if I took the square root of both sides is that x plus 4 equals plus or minus the square root of 25. So x plus 4 is equal to plus or minus 5. If that's true, then x plus 4 equals negative 5, and x plus 4 equals positive 5. Therefore, x equals negative 9. That's one of our solutions, or x equals 1. Okay, the second one here is in a slightly different form, but can be adapted. It's just in a very abstract form. Okay, what we would get is that if I took the square root of both sides, is that x plus a is equal to plus or minus b. Therefore, x equals a, negative a, plus or minus b. Okay. All right, let's move on to the third example here. Now, this is interesting. I don't have a square, I have a cubic here. So what I want to do again is get this constant over to the other side. So when you're in this extracting roots form, you want your constant alone on the other side of the equation. So for example, negative 343. And then I'm going to take the cube root. Now with cube root, that's different than an even root, because a cube root will not yield multiple answers, meaning we don't have to worry about the plus or minus. So in this case, we just take the cube root of negative 343. I believe that equals negative 7, excuse me. Cube root of a negative is still a negative. And then I would just add 3, so I get negative 4. Looks like that polynomial only has one solution. Okay, let's move down here to the quadratic formula. The quadratic formula is very powerful. It's very cumbersome, but it's very powerful. The solutions to this quadratic formula are negative b plus or minus square root b squared minus 4ac all over 2a. Okay, where in this case a equals 2, b equals 3, and c equals negative 1. Okay, so let's find our solutions using the quadratic formula. Negative b, which would be negative 3, over 2a, which is 2 times 2, which is 4, plus or minus the square root of b squared, 3 squared is 9, minus 4 times a times c. So a times c is negative 2, all over 2a, which is 4. So let's figure out what we got here and put it in a nice form. That's negative 3/4 plus or minus 9 minus a negative 12 is 21. So the square root of 21, which I can't reduce, all over 4. And that right there would be our two solutions. Notice that we have 2 here with the plus or minus. Okay, well, let's move on over to the last method called factor by grouping. Factor by grouping rarely occurs, but when it does, it's very convenient. So if I want to find the solutions to this equation, I could have up to 3 real solutions, right? Since this is a cubic. So what I'm going to do to solve this is I'm actually going to rewrite it. I'm going to rewrite it as 2x cubed minus 6x squared plus a negative 6x plus 18 and set it equal to 0. And watch how I group these terms. Okay, so I'm going to grab the first 2 terms, turn that into one grouped term, as well as the second 2. And in the first one, I'm going to factor out a 2x squared. That leaves me with x minus 3. In the second one, I'm going to factor out a negative 6. That also leaves me with x minus 3. This is desired, right, to see this x minus 3 showing up in multiple places. Okay, now as I look at the expression as a whole, I've got these 2 terms, and both have an x minus 3. So I factor out the x minus 3, and I'm left with 2x squared minus 6. Okay, now I can find and isolate using previously used methods. In this case, I'm just going to solve this linear equation. X minus 3 equals 0. So one solution will be x equals 3. And then I'm going to use an extracting roots method here. 2x squared minus 6 equals 0. Therefore, x squared, actually this isn't extracting roots, this is just solving algebraically, but x squared would equal 3. Therefore, x would equal plus or minus square root of 3. Okay, so look at that. I found my 3 solutions, x equals 3 and x equals plus or minus square root of 3. Let's continue on for a couple of more questions. Okay, so within the process that we've been using up until this point, when we set one side equal to 0, what we have been doing is finding the solutions. And the solutions when one side of an equation equals 0 is called the x-intercept. So we are finding the values for x such that y equals 0. That's called an x-intercept. A y-intercept is slightly different, but it's values for y such that x equals 0. So let's find the y-intercept for each of these equations below, and then we'll go back and we'll find the x-intercepts. All right, so the y-intercept for g in number 1 would be what I would get if I plugged in a 0. And clearly the first 2 terms, 6x squared minus 3 would disappear, 3x would disappear. I would get 5. H of 0, I would get 121. T of 0, I would get 5 as well. And Q of 0, I would get negative 15. So the y-intercept in 1 would be 0, 5. In 2 would be 0, 121. In 3 would be 0, 5 as well. And in 4 would be 0, negative 15. So let's go back and let's find the x-intercepts, also called the solutions. Okay, so it looks like g of x. If I want to find the solutions, I want to know where y equals 0. Therefore, I want to know where 6x squared minus 3x plus 5 equals 0. Likely, I'd have to use a quadratic formula here. I don't know, maybe I can factor, but I'm going to use the quadratic formula. So x will equal the opposite of b over 2a plus or minus the square root of b squared minus 4ac. Okay, it looks like, and this is, I'm glad I brought this question up, but if I took b squared, that would be 9 minus 4 times a times c. Well, that would be 4 times 6, which is 24, times 5, which is 120. Notice what will happen here. This number here will be negative, and we can't take the square root of a negative number. Therefore, g of x has no solutions that are real on the real numbers. Okay, it has no real solutions. That's a good one to bring up. I'm glad it kind of fell in there on accident. I didn't intend for that to happen. Okay, number 2, let's look at h of x. If I want to know where h of x equals 0, which is the x-intercepts, I could, in this case, factor this, or I could use some algebraic methods, but I'm going to factor it. So I want to know where, if I factored this, I would put an 11 here and 11 here. This is the difference of two perfect squares. This would be plus x, this would be minus x. And if I solve that, I would see that I have solutions at x equals negative 11 and positive 11. Those are my two real solutions. It looks like t of x is exactly the same as g of x. So yeah, we're not going to do that one, but we would say that g of x has no real solutions. That was nice and fun. Let's look at q of x. I'm guessing this is probably a factor by grouping. Let's set this equal to 0. We got x cubed minus 5x squared plus 3x minus 15. Notice how you've got this 1 to 5 ratio here, coefficients. So if I pulled out an x squared, I would get x minus 5. And if I pulled out a 3, I would get x minus 5. Very nice. And I want to know where this is equal to 0. Well, I can regroup these as x minus 5 and x squared plus 3. Okay, so where would this be equal to 0? Well, it would be equal at x equals 5. This is very interesting too. Where would that be equal to 0? Well, what you'll see is that x squared can never be equal to negative 3. Therefore, this will not yield any solutions. No solutions will come out of that portion. Therefore, my only solution in this cubic would be x equals 5. Okay, we got one more slide, you guys, and then we'll move on to part 2 using different types of functions and finding their solutions. Okay, this last slide, you guys, example 3, is just a verification that certain solutions are truly solutions to the equation. All that you would do in order to show that this is true is that you would be inputting said solution into the function and showing that it equals 0. So let's take this and in for x, let's plug in 4. Well, 4 minus 4 is 0, and 5 times 0 is 0. Therefore, since y equals 0 when x equals 4, 4 is a solution. Okay, likewise, if we were to do the same thing in example 2, if I plugged in a 0, clearly I would get 0. So 0 will check. If I plug in a 1, I would get 1 cubed minus 6 times 1 plus 5 times 1, which will come out to give me y equals 0. So 1 checks. And then if I plugged in a 5, I would get 125, which is 5 cubed, minus 6 times 25, which is 150, plus 5 times 5, which is 25, which again comes out to give me y equals 0. Okay, this is kind of like some students decide to guess and check. This is just a way to verify, okay? Don't ever guess and check. That will just take way too long. Okay, and then if I plug in a negative 11, negative 11 plus 9 is negative 2. If I square a negative 2, I get 4. 4 minus 4 is 0. So in this case, y would equal 0. So negative 11 checks. If I plug in a negative 7, I get a positive 2 squared minus 4. Again, I'm going to get y equals 0. So negative 7 checks. All right, guys, that's a lesson on finding the solutions to linear, cubic, and quadratic functions and equations. All right, hope it went well. Let me know if you got any questions.